question. There's actually contaminated data, which I will explain in class, but let's just assume that the data is not contaminated. And in class we had several groups roll 20-sided dice 100 times, and each group went to the board and wrote down their tallies. You were there, that happened, and how frequently each value was rolled. And what I did is I just took the list right off the blackboard and typed them in, and then I sorted them. Okay, so then we will basically want to draw a histogram of this. So we just want to look, if we look at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Alright, we don't need to go that far. That's fine. And there's one, if I go 5, 10, 20, 30, 40, 50, I can just squeeze above there. I'm going to have like 52 of something, but it's okay. Alright, so how am I going to count all these? It's kind of obnoxious, right? So I'm going to actually draw little lines for myself. I'm going to just say 1, 2, 3, 4, 5. That's a group of 5 of something. 1, 2, 3, 4, 5. Here's a group of 5. Here's a group of 5. They're not totally lined up, are they? Dunk. This is kind of obnoxious, but hey. 2, 3, 4, 5. Ding, ding. That's the way it goes sometimes. 3, 4, 5. It would be more obnoxious if I made you sort them. I'm not going to make you do that. 3, 4, 5. Is it all the way out to there? 1, 2, 3. I guess it is. 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 5, and so on and so forth. Okay, so something to group them will help you. All right, so then the first I'm going to say there's one copy of the number 0. How many ones are there? There's 5, 6, 7, 8, 9, 10, 11, 12. So it's kind of like that. So I have this bar right here. That's 12. If you're worried that I won't be able to read your graph, then you can just go like this. Put down the frequency there. Ah. Frequency. Frequency is ambiguous because this is a frequency of frequencies, so it's kind of weird. Okay, 10, 20, 30, no, 5, 10, 15, 20, 21, 22, 23. So there's 23 of these guys. Alright, so let's count up to here. I'm being a little more sloppy than I was on the answer key. Okay, so let's see, how many 3s? I have 5, 10, 15, 20, 25, 30, 35. It looks like there's 35 of them. So it goes up to here. So there's 35 there. What about how many 4s? Okay, I'm just shy of 5, so I'll hold that all. Let's see, I have a count from this side. 5, 10, 15, 20, 25, 30, 35, 40, 44. So there's 44 4s. And that would be about there. Whoops. Don't you wish you had an electronic eraser? It's so cool. Okay, how many 5s? Alright, 5, 10, 15, 20, 25, 30, 35, 40, 45, 51. Wait a minute, my other tally says I have 52. Which one's right? One of them's wrong. 5, 10, 15. I think I counted this as a group of 5 when it's really not a group of 5. I think 51 is correct. Whoops. My answer key is wrong. Guess I gotta go fix it. Okay, what about 6? I have... Wow. Okay, so I have 5, starting here, 5, 10, 15, 20, 25, 30, 34, 35, 36, 37, 38, 39, 40. Yep, I counted that one wrong too. Whoops. Okay, how many 7s? I have 5, 10, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 24. Hey, at least I got that one right. Ah! How many 8s? I have 5, 10, 12. So that one is right. How many 9s? I have 8 of those. And how many 10s? 1, 2, 3, 4, 5, 6 of them. 11s. 12 and 13. There we go. Yep. But then it says you're supposed to say something about it. Oh no, it says talk about it. What a bummer. Okay. Please graph the frequency and comment on the shape that results. Well, I'm just going to tell you what to say because you might not think of what to say. So this shape kind of looks like a U shape. It curls a little bit like that. But it basically looks like the letter U upside down, and then this looks like the letter U in the other direction, like that way. Right, so you have like 2 letter U's. Is essentially what's going on. It's not necessarily what you'd expect. If you had 2,000 groups do this experiment, see, it will never get smooth. That's the crazy part, because even though you'll get more numbers here on this axis, you're still going to be like some gap between here and here. It's going to be a straight line. These look kind of smooth eventually, but there's always going to be a jump from here to here. Well, I've run the experiment and it just does that. And you can look at the results on Blackboard. I posted that picture. So there's always going to be this jump between how many 4s you have and how many 5s you have. And the one from 5 to 6, but this one just isn't visually as disgusting. But this jump from 4 to 5, it just looks disgusting. It doesn't look smooth. Well, that's not a smooth function. The other thing you should realize is this can go out. Like theoretically, it goes out. In practice, it won't. But you rolled it 100 times, so in theory, you could have rolled all 100 the same value, which is crazy. Nobody's going to do that. But in theory, this goes all the way out to 100, and there's some probability that it could go that far. Anyway, hopefully that's enough explanation. I will go fix my answer key now.